Welcome to Unit 11. In Unit 11, we're going to be solving systems of equations. What's that? Well, it's two or more equations. We'll just do two. And it turns out where a system of equation is solved is where the two lines intersect. All right, so write an equation for the blue line you see there. Well, its y-intercept is 0, 5. Its slope down 1 over 2, right? Down 1 over 2. So the slope is negative 1/2. The y-intercept is 0, 5. And so the equation is y equals negative 1/2 x plus 5. Now we're going to graph the line y equals 2x minus 5 on the same coordinate plane. So the y-intercept is 0, negative 5. The slope is 2, so over 1 up 2. And so I'm going to do that one in red. And where do the two lines intersect? That's what you're going to be finding in every problem in this unit. Well, the two lines intersect right there at the point 4, 3. And you would say the solution to this system, we have two lines. One, that's negative 1/2 x plus 5. The other is y equals 2x minus 5. What is the solution to this system? Where they intersect, 4, 3. Right, so what would be the solution to this system? Where the two lines intersect right there at what? 6, 3. Okay, two or more linear equations are called a system, all right? The solution to this system isn't a number, it's an ordered pair. So what we're going to do is graph both of them. So let's graph this first one, and we'll graph that in y equals 5x minus 8. So you're going to make a little sketch, or you're going to go to desmos.com and use that. You can graph there. And so y equals 5x minus 8. So you can go to 0, negative 8. That's our y-intercept. Then our slope is 5, over 1, up 5. So I'm at 3, right? Negative 3 there. Then I go over 1, up 5 again, and I'm at 2. So if you're sketching this, right, you're going to have to be a little more accurate than you've been. 2, 3, 4, 5, 6, 7, 8. Then over 1, up 1, 2, 3, 4, 5. Then over 1 again, and up 5. 3, 4, 5, right? And then we're going to draw a line, and that's our first linear function. Okay? In a sketch, it would look like this. Then we're going to do it again for y equals x. What is that? The y-intercept is 0, 0, and the slope is 1. Over 1, up 1. Over 1, up 1. Look right there. That is where the two lines intersect, right there, right? And so on a sketch, right, you're going to 1, 1, and 2, 2, and 3, 3. Those are all good intersections. And so I want to graph that. All right. And so the solution of this system is at 2, 2. Now, what is that point, 2, 2? Well, it's the only point that's on both lines. It is the only point that makes, how is this phrased? What is the one ordered pair that makes both equations true? So let's see that. So if I let's put 2, 2 into this point, where if you put it in the bottom equation, you get 2 equals 2. Well, that makes sense. And if you put it in the top equation, you get 2 equals 5 times 2 minus 8. Is that true? 5 times 2 is 10. 10 minus 8. Yeah, you get 2 equals 2 again. And 2, 2 is the only ordered pair that works for both. Like 3, 3 works on the bottom one, right? But does not, it's on the blue line, but it's not on the red line. So it doesn't make the red one true. Okay? You're looking for the one ordered pair that works for both. And where does it occur? Where the two lines intersect, cross. All right, what is the one ordered pair that can make both of these true? All right, so the top one has a y-intercept of 0, negative 6, and a slope of 1. So we're going over 1, up 1. There, graph that right there. And then the other one has a y-intercept of 0, 0, and a slope of -2, right? 0, 0. The slope, this is the slope of 1. This is the slope of -2. So down 2 over 1. Down 2 over 1. There it is. That's where it hits. Right there. And so it intersects at 2, -4. Let's try this one. All right, so the top one has a y-intercept of 0, 5, and a slope of 2. That's over 1 up 2, over 1 up 2. Now the bottom one is y equals 7. So that's y equals 0x plus 7, right? What's the slope? 0. That's a horizontal line that goes at 7. All right, so right there. So where do they intersect? Well, first of all, realize the second equation has to have a 7, right? We're looking for a point where both the x and y are the same. It's right there, and it's at 1, 7, right? When y is 7, the bottom won't become 7 equals 7. When you put 1 in the top, you get 7 equals 2 times 1 plus 5, which you also get 7 equals 7. This is the only combination that works for both equations. It's right there, and that's called the solution, and it's at 1, 7. All right, so we're going to check if 2 and 9, there's 2, 9. 2, 9 is the solution here. So now we could graph it and all that, and we will in a second, but let's just see if it works, right? I put 9 where y is, 2 where x is, and I get 9 equals 14. No, it's not on that line. Let's just check it in the other equation. We don't have to do this, but 2 times, it does work for the top equation, because the top equation you get 9 equals 9, but it does not work in the bottom equation, okay? And so the answer to that is no, all right? So let's try this one, check 1, 7. So we're going to put 7 equals 2 times 1 plus 5, and 7 equals 7 times 1. Yeah, both of these are true. 1, 7, this one right there, is the solution to this system. All right, and there are the two lines. All right, so you can check, right? If you, especially, you're not using graph paper, you're not using a grid, and you're not sure you've got the right answer, you can check it. You can put it into the equation and see if it's the right one. All right. So the solution is where they intersect. So what if they don't intersect? What then? Well, let's look at this. These have the same slope, right? And so we should know what that means. It means the lines are parallel. The top one has a y-intercept of 0, -8, and a slope of 2. The bottom one has a y-intercept of 0, 4, and a slope of 2. And these two lines, since they have the same slope, should be parallel. Well, what does parallel mean? Parallel means that they will never intersect, right? So anytime you have parallel lines, that means the same slope but different y-intercepts, there is no solution. These do not intersect. Right, now these have the same slope, but they don't have no solution. What this is the same line twice, right? So you have 0, 7 is this y-intercept with a slope of -4, so that's down 4 and over 1, down 4 and over 1. And then you have the same line, so there's the, let's say this is the top version of that in red, and then you do it again in blue. Well, it's going to be right on top of each other, right? And so that's sort of silly, right? So how many times do those intersect? They intersect infinitely, right? So we say this has infinite solutions. It's the same line twice. So the same line twice, infinite solutions. Parallel lines, no solution, right? Most of the time, they have one solution where they intersect. That's the whole thing. All right, so let's practice. So the top one has a y-intercept of 0, 6, and a slope of -3. I've been doing red for the first one, so slope of negative red. There you go, red. So down 3, 1, 2, 3, and over 1, down to 3 and over 1. And so this is my top equation. The bottom equation has a y-intercept of 0, 0, and a slope of -1. So that's down 1 and over 1. And that's this one right here. Right. So where do they intersect? Right there. What's that? That is 3, -3. Right? Well, let's just see that. When x is, I'll do the bottom one first. When y is -3, x is 3. Right? Whoops. Right? -3 equals -3 if you do that. The top one, when y is -3, x is +3. Right? You get -9 plus 6. Yeah, that equals -3. That is the one ordered pair that works for both equations. It's the one ordered pair that's on both the red and the blue line. All right, now you could check this by graphing the whole thing, but what I'm really after is check if -8, 3 is a solution. So we're going to do a little fractions here. Y equals -1/4 times -8. Oh, plus 2, and this has to equal 3, right? The y is 3. This cancels, and you get -1 times 2 is -2 plus 2. I'm getting 3. Oh, and the negatives cancel. 3 equals 4, so this is no, all right? This is no. Let's see if we can check if -4/3 is correct. Here we're going to put 3 in for y. I'm putting it back into the top one. Equals -1/4 times 4. This looks better. All right, so no, it's -4, right? The two negatives cancel out and you get +1. 3, yes, that's the one. -4/3 right there is where the two lines intersect. Okay, this is y equals 3, the red one. The other one has a y-intercept of 0, 2 and a slope of -1/4. And the two intersect at -4/3. That's the solution. That's the one that works in both equations. All right, so these both have the same slope, but they have different y-intercepts. What does that mean? It means they're going to be parallel, and it means how many times are they going to intersect? Never. So we're going to say no solution, right? And we're just going to graph it to show the +1/2 slope, over 2, up 1. All right, that's the top one. The bottom one, 0, -3, same exact slope, looks like that. And hopefully I'm going to graph these so they look like they never will intersect, because they are parallel. All right, good luck with the homework.